All right, next section we have is 3.6, trigonometric functions. This section, there's not a lot going on. It's really just giving us some new derivatives to take a look at here. Getting practice differentiating these will occur throughout the following next few sections. So this section is very light. It's only this one example. So here we are. So collectively, these two derivatives here are your most important ones because technically when you're armed with quotient rule and when you're armed with quotient rule, you can figure out any of these other ones. So quickly here, derivative of sine is cosine and the derivative of cosine is negative sine. So the one thing I do want to show you all is how I sort of remember this. In my head, I kind of have this little cycle where I think of sine of x, and then I think of differentiating to get cosine of x, and then I differentiate again, and I get negative sine of x, and then I differentiate again, and I get negative cosine of x, and then one last differentiation, and we get that. So there's this cycle, and it just repeats. So no matter where you start, if I start with cosine and I do 4 derivatives, 1 derivative, 2 derivative, 3 derivative, 4 derivative, we land right back at cosine. So for either sine or cosine, with whether there's a plus in front of it or a negative sign in front of it, every 4 derivatives it repeats, and every 2 derivatives it flips sign. So I just have this little cycle in my head that I think about. For these derivatives down here, the remaining 4, I'll go ahead and just say that the derivative of tangent and the derivative of secant are far more likely for you to encounter and work with than the cotangent, cosecant derivatives. So just be aware of that. You will probably notice a bias towards secant and tangent, and that's just because they do typically show up more often than the other ones do. So with that being said, let's go ahead and take a look at example 1, where we want to know the equation of the tangent line to the graph of y equals tan theta secant theta at theta equals pi over 4. So let's go ahead and remember that for any line, right? For any line, we just have y minus y1 equals our slope times x minus x1. Now for us, we can, instead of using x here, we can just say theta if we want to. So we can just say theta minus theta 1 if you prefer. But if we go ahead and solve this for y, not that we need to, but if you want to solve it for y, this would be y1 plus m times x minus x1, or theta minus theta 1. So that's just for any line, point slope form, and then just adding y1 to the other side. A lot of times on web work, it's solved for y, so that's why I am familiar with and in the habit of doing this. Now for a tangent line, so practically the same thing. The only difference is for a tangent line, we have our slope is the derivative at our x value, x1. Or if you do it in the other notation, the Leibniz notation, this would be dy dx at x equals x sub 1. So what we could do here is go ahead and just say that y equals, well, what's the y value? The y value is just the value of the function. So plug in x1 into the original function, and then our slope is f prime of x1 times x minus x1. Now usually when I write this up, I use a instead of x1 just because I think the 2 different x's here can just be a little confusing in the subscript. Some people, it can be a little overwhelming at first, so a lot of times I say the equation of the tangent line 2f at x equals a. I just write this as a equals f of a, or excuse me, y equals f of a plus f prime of a times x minus a. Same exact thing, just making this replacement x1 for a, but I definitely think this just looks a little bit cleaner. So that's what we're going to do here. So let's go ahead and take a derivative of this. So dy d theta, in this case, since theta is our independent variable, we'll get, well, we've got a product rule. We've got two trig functions multiplied together. So the derivative of tangent is secant squared theta times the second function left alone, which is another secant theta, plus our first function, tangent of theta left alone, times the derivative of secant of theta, which is secant theta times tangent theta. So now this is a good opportunity for us to actually go ahead and simplify things before we go ahead and plug in our pi over 4. So I'll just go ahead and do secant cubed theta plus secant theta tangent squared theta. Okay? So now, if we're going to go ahead and evaluate this at theta equals pi over 4, we just have to go ahead and know what these values are. So make sure that on any assignments, you are actually evaluating what this is. You have to know what tangent, secant, sine, cosine, all of them are at the common angle. So anything on your unit circle, you have to be able to know. So in this case, secant, remember here that secant of theta is just the cosine of, 1 over the cosine of theta. So we know that the cosine of pi over 4 is root 2 over 2. So this means that the secant of pi over 4 is just the reciprocal, 2 over root 2. So if we cube 2 over root 2, we should have 2 cubed is 8, root 2 cubed is 2 root 2, plus we have another 2 over root 2 for secant, and then we know that tangent, well actually we know that tangent is, of course, sine over cosine, and we know that cosine and sine are both the same value at pi over 4. So if cosine and sine are the same value at pi over 4, then their ratio must equal 1 at pi over 4. So this ends up becoming just times 1 squared. And if you go ahead and simplify all of that, we should get, let's see here, we can go ahead and simplify this. If we add them together with a common denominator, this should be 6 over root 2. So that's the slope of our tangent line, not our final answer. So that's our slope. So that means our equation of the tangent line, if we're using thetas, would be y equals our y value, which we need to get. So let's go ahead and figure this out. Y at theta equals pi over 4 is just tangent of pi over 4 times secant of pi over 4, which is 1 times 2 over root 2. So y equals 2 over root 2 plus our slope of 6 over root 2 times theta, times the quantity theta minus pi over 4. And that's the equation of our tangent line.